Now let's see in short what we did in the chapter, throughout the chapter, that is a chemical kinetics. So chemical kinetics, we start a chapter with the rate of reaction. Rate of reaction. We start with this chapter. We start with the chapter with the rate of reaction. In rate of reaction, also we did the two types of rate. The one was the average rate of reaction, and the second was instantaneous. Average rate of reaction means where I said that time interval is very large, while in case of instantaneous, the time interval was very small. After the rate of reaction, next we did rate law. The next part which we did is rate law. Rate law, where we express the rate of reaction in terms of the concentration of reactant. It is a mathematical expression which expresses the rate of reaction in terms of the concentration of the reactant, where we learn about the two powers, that is x and y, where x and y power may be coefficient or it may not also. How to know the values of x and y? Then simply I said you have to perform the experiment, and from the experiment we get some data, and from that data we deduce the values of x and y. After the rate law, in the same part we did something about the order rate constant. Okay, before rate constant we did something about the order of reaction. In this order of reaction, again we learn about the two things, that is called as a zero order reaction and first order reaction. So here we did for the zero order reaction, we learned about these two in detail, and the first order reaction again in detail. Now in case of zero order reaction, what is zero order reaction? Then simply I say that zero order reaction is a reaction which takes place in which the rate of reaction does not depend upon the concentration of reactant. And we derive a formula for the K for the zero order reaction. For a K formula, for K we got a formula A0 minus AT upon T upon T, and as well as we did a formula for T half also, and the formula was A0 upon 2K. Means in case of this, I said that T half is directly proportional to the initial concentration of reactant, and in the same case I said that rate is independent of, rate does not depends on the concentration of reactant, that is the rate of reaction is constant. After that we did the first, okay, in case of zero order reaction, we also studied that the total lifetime of the reaction, that is a total lifetime, TLT, total lifetime of a reaction is 2 times of half-life period. Means after 2 half-life period, the zero order reaction will get completed. In zero order reaction, I said that the time required for the completion of the first 10% of the reaction and the last 10% of the reaction or middle 10% of the reaction is going to be same, because the rate of reaction remains constant throughout. Then we did something about the first order reaction. What we did first order reaction in the case of first order reaction? The first order reaction here I can say, again what is first order reaction? It is a reaction in which the rate of reaction depends only on single reactant, and that to the power raised to 1. Here also we did the same thing, the one which I did in first order reaction, zero order. Here also we calculate a formula for the K. The formula was 2.303 upon T log to the base 10 A0 upon AT, where A0 is initial concentration we say, and AT is the concentration of reactant after time T. And T half, for T half we get a formula 0.693 upon K. From the formula, I can say that T half does not depend on the initial concentration of reactant. So here the half-life period of this first order reaction does not depend on initial concentration of reactant. Here in the case of this, I can say that rate is equal to K into molar concentration of A, that is rate of reaction is directly proportional to the concentration of single reactant with the power 1. Okay, In the case of this, T half, T lifetime of this reaction is infinity, means cannot be predicted. We just we did the derivation also for the same, that here the lifetime of the reaction means when the reaction, how much time the reaction will take, it can't be predicted directly. Now after this order of reaction, we did something for about the order of reaction. It is represented by the small letter n. After order of reaction, in the same chapter we did something about the rate constant. Rate constant, that is K. We write its unit also. Its unit was m raised to 1 minus n liter raised and per time. Depending on, every time I said, never in a numerical or in a anywhere, never write to time per time. You have to mention the unit of time. It is in minute, second, hours and hours. It's only for the difference I'm writing time. Depending on whatever the unit is, time unit is given, you have to mention that unit. So this we did about the rate constant. What will be the unit of rate constant? It totally depends upon the order of reaction. Zero order, it is going to be m raised to 1. First order, m raised to 0 means the no molar concentration. Second order, third order, and so on. Order of reaction help us to decide the unit of rate constant, or in other word I can say unit of rate constant also help us to predict the order of reaction. After the rate constant and the order of reaction, the next we did about the pseudo first order reaction. Pseudo first order reaction. What is pseudo first order reaction? So simply I will say it is a reaction in which the pseudo first order reaction, it is a reaction which is actually of higher order but act as a first order. Means rate of reaction is actually of second, originally the reaction is of second order or third order, but are found to behave as a first order reaction, is called as pseudo first order reaction. After this we have the mechanism of the reaction. The mechanism which express the which on the basis of which we have the two types of reaction, that is called as okay. So these two type we have on the basis of the mechanism, that is elementary reaction and the second is complex reaction. Elementary reaction and complex reaction. Elementary reaction, I said elementary reactions are those reactions which takes place in a single step, while the complex reactions are those reactions which takes place in two or more than two steps. In case of elementary reaction, here the power and coefficients are same. Means I can say in case of elementary reaction, x and y, that is powers, are nothing but coefficients. While in this case, we cannot use such type of word that power and coefficients are same. The rate of a complex, now in case of elementary reaction, order and molecularity is same. Means the reaction, because the power tells us about the order and coefficient tells us about the molecularity, and if the power and coefficient is same, it means the order and molecularity is also going to be same. While in this case the molecularity concept itself not applicable. For a complex reaction we cannot write the molecularity step. For in a complex reaction, the reaction which takes place in two or more steps, in that case there is a one step that is called as a slow step, or also known as rate determining step, is a very important, because the rate of a complex reaction depends upon the rate of slowest step in case of complex reaction. So this is elementary reaction and complex reaction. After elementary and complex, we did something about after the elementary reaction and complex reaction, we did something about the effect of temperature on the rate of reaction. So here the rate law we did, the rate law which tells the effect of the concentration, effect of the rate, effect of the concentration on the rate of reaction, and then we have the effect of temperature. Okay, but before that also we did collision theory. Collision theory, according to which for a reaction to take place, some three criteria are required. That reactant molecules should colloid. The second criteria is that activation energy, and the third criteria is that molecules should be properly oriented. If all three criteria are obeyed or followed, then only the reactant get converted into product. After collision theory, with that temperature, effect of temperature. And while talking about the effect of temperature, we also talks about Arrhenius equation. That is, Arrhenius equation comes under the same effect of temperature. In Arrhenius equation, we did two formulas. The one is directly the Arrhenius equation. The second one, if the temperature is changed, what will happen to the rate constant? That another one. And then the last part which we did is effect of catalyst. We did the effect of catalyst. So we start the chapter and the chapter ends with the effect of catalyst. So these are the some important points of the present in a chemical kinetics. Catalyst, effect of catalyst. In effect, catalyst, I said that rate of reaction it increases, and how it increases the rate of reaction, then simply by decreasing the activation energy.